Our next speaker will be an engineer, Kellesia Ebanks. She will speak to us on air quality and ventilation in buildings, implementation and maintenance. Kellesia Ebanks is a certified professional mechanical engineer who specializes in the building service and energy engineering field. She is the manager of engineering solutions at Dem Dock and Company Limited. She is a graduate of the University of the West Indies, Mona, and Brunel University, London, where she achieved her master's. As a young leader in the sciences and the theater arts, Kellesia received the prominent Prime Minister's Youth Awards for leadership in 2018. Help me to welcome Engineer Kellesia Ebanks.
Hello, good morning. Am I sharing my video? No, I'm not. 1 second, let me figure this out.
Yes, we are seeing your screen, Kellesia.
Oh, you're seeing my screen. Okay, great. So good morning again, ladies and gentlemen. My video, I want to share my video. Okay. Yeah.
Okay, we're seeing you and we're also seeing the presentation.
Okay, great. Give you a nice background. All right, good morning, everybody. Let me get started. I stayed home today for the quiet. It's a bit noisy at my workplace. All right. All right, so today I will be speaking about indoor air quality and ventilation during the COVID-19 pandemic and beyond. So I will be also touching on maintenance and so on as it relates to the whole solution of HVAC, heating, ventilation, and air conditioning. As a building services engineer, one of the most common questions I am asked in today's climate is how safe is it in a commercial building with an air conditioning system consistently recirculating the air? And I hope this presentation will be able to answer the questions that we all definitely have. Okay, so it is very important, essential that engineers understand the fundamentals of indoor environmental health. What is most important is not only the comfort, but the health and well-being of the persons that are occupying a building. After all, most of our time or most of our lives are spent in buildings, whether it be at work or at home. So the design, installation, operation, and most definitely the maintenance of a building and the HVAC system is significant to the health of the building occupants and to the life of the building. So let's get right into HVAC systems and COVID-19 right now. There are several reports over the past couple months coming out indicating that the air conditioning system can transfer COVID-19. However, upon investigation and smear samples being taken, we have discovered in a research done by Lu et al., we have discovered that it's not the air conditioning system transferring COVID-19 droplets, but definitely the airflow produced by the air conditioning system within the space. So it is a fact, the airflow in the space is able to transfer very fine aerosolized COVID-19 droplets. So how do we deal with this? Now, there are several recommendations made by international bodies who specialize in HVAC. So I'm going to share a few of these with you today. Now, the first and what I believe to be the most important recommendation is to increase, or in an instance where there's no outdoor air being introduced to a space, to introduce outdoor ventilation to a space. Why do you need outdoor air to a space? Why is it necessary, especially in this climate and definitely beyond? It is important because a ventilation system is what provides fresh air to the space to not only oxygenate the space, but to dilute, remove, and flush contaminants from the space. So a properly designed ventilation system with a proper introduction and exhaust of air will definitely achieve a healthier and safer indoor air environment. Another recommendation is to improve central air filtration to a minimum of MERV 13 rating to reduce the recirculation of air pollutants. So what we know of a typical air conditioning system is that it recirculates and cool air within a space. Now, in order to reduce the recirculation of air contaminants, and they are vast, a space has any number of air pollutants at any given time. So to reduce the recirculation of these pollutants, we are recommending a minimum of MERV 13 filtration to central air systems. Now, this is not without its flaws. So before a building manager goes ahead and introduces MERV 13 filtration to a system, he or she must first ensure that the system is capable of managing the extra external static pressure that is introduced definitely by the filtration system. So this is something that should be confirmed or checked in with an engineer or a trained professional, because not all systems are designed to manage the extra resistance to airflow that is introduced by MERV 13 filter. So even if the system is not able to support it, definitely introducing a higher grade of filtration will reduce the recirculation of contaminants. Another recommendation is for the introduction of ultraviolet germicidal irradiation lamps. Now, what these, if you see as you can see here, we have an air handling unit, and what we have here are rows of UV lamps. So what happens is that the air is being recirculated from the space. Here is the return port. So the air comes back from the space, goes through these filter channels, and then is passed through the unit's coil, the cooling coil. And then once the air is passed through the coil, it goes through the UV lamps where the microorganisms that are present in the air are neutralized. Now, microorganisms vary widely: bacteria, fungus, mold, and definitely viruses that cause diseases like COVID-19. So this is quite effective, but not 100% effective. No air purification or neutralization system is 100% effective, but this is, if properly sized by definitely an engineer, a professional engineer, then it can be quite useful in neutralizing microorganisms in the air. Another positive effect of the UV lamps is that it reduces air conditioning maintenance or the need for system maintenance, because it over time, it cleans the coil by killing bacteria, fungus, mold that will get lodged onto the coil of the air handling unit. So that's another positive for that equipment technology. Another technology that we certainly new to me and quite a few of my colleagues is ionization technology. So commercial ionization is another solution that we can consider in the commercial application. So what it does is, as you can see in the image over here, an ionizer here at point 1, what it does is it creates an electronic charge that produces millions of positive and negatively charged oxygen ions that travel through the duct system here. Here you have the positive and negatively charged ions traveling through the duct system and are introduced to the space via the duct. So once in the space, they are able to interact with airborne particles, germs, and other gaseous contaminants. Now, through oxidization, these ions are able to kill pathogens by robbing them of life-sustaining hydrogen to break down airborne mold, bacteria, viruses, and other varieties of VOCs into harmless compounds like oxygen, CO2, and water, H2O. Also, ionization increases the efficiency of your filters. Now, that is an important point that I want to note. When the positive and negatively charged ions are introduced to the air in the space, what they do, when they, through the process of oxidation, they clump to the different particles that are in the air, and through that clumping mechanism, they create heavier compounds. So the compounds that were before suspended in the air or are now heavier, and as a result of the clumping effect, they sink to the ground because they're heavier and they're larger. They either sink to the ground, neutralize, they sink to the ground and settle on surfaces that are routinely cleaned, or they go back to the system. They go back to the system via the return air duct, where they are more easily filtered by the media filter in the return of the unit. So what it does is create an effect of increasing the efficiency of the filter. So research has shown that it increases MERV levels by 4 to 5. So even if you have a low MERV filter, ionization by creating larger compounds in the air is able to more easily filter the particles going back to the return and then going back into the space. So it is very effective because the negative and positive ions, they travel with the air. So it's not localized to just the coil of the unit like the UV lamps. The ions actually travel to the space and clean the space as it goes along. Here we have an image of what it looks like installed along the coil, along the width of the coil. So again, in everything, in all of these systems, it's not just a plug and play type of situation. An engineer has to, with the knowledge, a trained professional engineer with the knowledge, has to go in, do the sizing, see, understand what the requirements are, and make recommendations for proper installation. Another recommendation, the final one that I'll share, is the use of portable air cleaners with HEPA filters. And these are quite good for something that you can do right now, very quick and easy. These filters are very good at removing airborne particles of a certain size, mold, viruses, bacteria, dust, smoke, and also odors from the space. But what we have to look at when we are purchasing these portable room air purifiers is the grade or the efficiency of the filters. I think the best one that I've seen locally filters down to 0.1 microns, which is really good. That is a medical grade air purification unit. So this is another option that we can look at along with the other options for the commercial application. So those are things that we can do right now to alleviate the stress of the COVID-19 pandemic. But what I want to implore persons and professionals is to consider these going forward, to constantly continue to improve the indoor air environment. So what is indoor air quality and why is it so important? Well, indoor air quality is defined based on the level of contaminants in the indoor air and the thermal conditions. It is all about the occupant. It is all about the occupant and his or her, their well-being and comfort within a space. So if the space has a high concentration of whatever contaminant, they're not going to be comfortable. They're going to be sick. They're going to be absent. It's just not going to be good for their health. And if they're not thermally comfortable there, again, it's not going to be a good environment for your building's occupants, and it's all about them at the end of the day. According to ASHRAE, acceptable indoor air quality is air which there are no known contaminants at high or harmful concentrations as determined by cognizant authorities, and with which a sustainable majority, that is over 80% or more, of the people exposed do not express dissatisfaction. So as you can see, it is centered around the occupants of the space and whether or not they are physically okay, are they comfortable, and are they healthy. So that should be at the forefront of every engineer's design, implementation, and maintenance plan and strategy. As I said, the purpose of an effectively designed HVAC, heating, ventilation, and air conditioning system is always to create thermal comfort and a healthy building indoor environment for the occupants. So you don't want a situation where the occupants are too cold or too hot. You want them feeling comfortable and are healthy. So HVAC systems are designed to maintain the thermal comfort, that is the air conditioning system is designed to maintain a comfortable temperature within the space for the occupants, and to maintain and control the indoor air contaminants, we look to the ventilation and exhaust system. So a properly balanced air conditioning and ventilation system should create healthy indoor air environment for the occupants within the space. Why is ventilation so important in maintaining indoor air quality? Well, as I said, we spend most of our lives indoors. And inside, we have a wide variety of air contaminants. And in order to control the level of air contaminants, we have to introduce fresh air and we have to ventilate the space. Now, ventilation, as said before, is used to control indoor air contaminants. And here I have a list of just a small portion of the variety of contaminants that are within a given space, certainly in commercial environments. And I don't want to scare anyone, but it is vast. The list is vast. So we have radon, which is a radioactive element found in building construction and materials, certainly in granite. We have indoor aerosols, which are suspended particles in the air like dust, smoke, and those are typical to environments like, for example, like cement factory, flour mill, bauxite environments that have a rich type of exhaust in the air. Certainly VOCs, volatile organic compounds, which is a form of gas found in items such as cleaning products, furniture, pesticides, adhesives, and the list goes on and on and on. Every morning you see somebody cleaning a space, you have persons spraying perfume, you use lotion on your skin, the carpets are emitting volatile organic compound, the shades, the blinds. It is all around us. Carbon monoxide, from incomplete combustion, bioaerosols, bacteria, fungi, and viruses, which contribute to sick building syndrome, which we will get into, and building-related illnesses, asbestos, etc. So this is just a short representation of the variety of indoor air contaminants that can exist, certainly in a commercial application and residential, I might add. Now, as engineers, we have to design systems for the application, for the specific application, based on how not only human occupancy, but how the space is used and the different design parameters. Now, airflow control parameters that are used on a daily basis to design ventilation systems include human occupancy, concentration of indoor air, pollutants, the size of the space, and the heating and cooling load. Certainly human occupancy, because we can design a system based on the rate of outdoor air per person recommended for the specific application. So the various standards, we do not have a local standard for this, but we look towards the ASHRAE standards to guide us as it relates to the rate of air per person recommended for a specific application. And the rate of air recommended per person is different for a variety of applications. Certainly you wouldn't expect the same rate of ventilation per person for a person working out in the gym versus a person seated at their desk doing sedentary work, because the level of metabolism is different, and the materials within the space are different, so it varies. Concentration of indoor air pollutants. Certainly with the different levels of concentration of pollutants, we want to design the ventilation system to ventilate and dilute pollutants from that space based on the concentration, size of space, ventilation rate per unit area for, again, specific application, and heating and cooling load. The ventilation rates, for example, for a warehouse is defined based on the need for cooling. In Jamaica, typically we use human occupancy and the size of the space to design a ventilation system. Concentration of indoor air pollutants are more typical to the industrial environment. Now, how do we classify indoor air quality or indoor air? Here we have a table from a European standard, which is able to categorize indoor air quality from level 1 to level 4, with level 1 being high indoor air quality and level 4 being low indoor air quality. Now, the indoor air quality classification definitely depends on the level of pollutants in the air. We use internationally, we use carbon dioxide levels, and why it is used as a proxy indicator of indoor air quality in buildings occupied by people, where pollution is mainly due to human metabolism, like office buildings. So it is an easy compound to detect, and easy, it's not necessarily a pollutant, because it doesn't do harm as it relates to the human body, but in high concentration, it definitely indicates poor indoor air quality. So what we have here is how the different categories are defined based on the parts per million of carbon dioxide in a given sample. So for indoor air level 1, which is high quality indoor air, the typical range is less than or equal to 400 ppm above the outdoor air level. The outdoor air carbon dioxide level is usually between 350 to 450 ppm, give or take. So good indoor or high indoor air quality is usually around 800, 850 ppm. And the list goes on, where we find very poor indoor air quality being around 1400 ppm of carbon dioxide parts per million. So this is how we are able to detect and tell if the indoor air quality is high or low. And when we have integrated systems and you have a carbon dioxide sensor connected to the ventilation system, once the carbon dioxide levels are detected to be at a certain level, then the ventilation system is manipulated to control and maintain a certain level of carbon dioxide concentration within the space. That's if you have a mechanical system. Many applications use natural ventilation. So that's not the best system for a commercial application. For commercial applications, we definitely prefer to use mechanical ventilation, which is able to control the indoor air quality in a space. So this is just an example of why we need different standards for different applications. Here you have somebody in a gym versus somebody at a desk. So definitely different ventilation rates for different applications, because different applications will have different rates of contaminant production and the different types of contaminants in the space. So this is an excerpt from ASHRAE Standard 62.1 2013. So it is showing here highlighted in yellow at the bottom of the page an office space and the recommended outdoor ventilation introduction rate that is recommended by the standard. Here the standard is recommending 5 cubic feet per minute per person. So if you know how many persons will be occupying the space on a daily basis, you will design your system to properly ventilate that space for the given amount of persons. If you're not sure, then you can also use the CFM, or cubic feet per minute per square foot calculation, where they recommend 0.06 CFM per square feet. And what I usually do when I'm designing a system is to incorporate both, and whichever one is higher, that's the one I go with, because more ventilation, the better. What we need to do is ensure that the ventilation and the air conditioning systems are designed in harmony, because the ventilation system is introducing fresh air to the space and also removing contaminated air. So when that fresh air is introduced to the space, it is definitely coming in at a higher temperature, or it is coming in at highest temperature it can come in at is outdoor air temperature, which is much higher than the design temperature for the space. So in designing the system with indoor air introduction, you have to ensure that the load is calculated to consider the high temperature of the higher temperature of the air coming in. And also, as Engineer Boyd was saying earlier, you have to be cognizant of the design. So you don't want to do a design where the outdoor air is coming in from a low point. For example, in New Kingston, you can't bring in the outdoor air from a low point, because there's traffic, so there's a lot of contaminants at low level due to traffic in a space like that. So you have to find somewhere high on the building to bring in that fresh air that is going to be as clean and has as little contaminants as possible. And also another thing to consider is the location of the exhaust from the building. You do not want to exhaust air too close to the input, or where air is coming into the space. So just common sense, but definitely something to note in doing your engineering design. This is why when we are seeking engineering design, it must be from reputable engineering firms that have a great track record and a high level understanding of the equipment and technologies. So to control the indoor air quality and overall environmental health of the building and its occupants, the HVAC system must be designed and installed and maintained to meet the relevant local and international standards. And of course, using engineering calculations based on the outdoor and indoor design conditions. So not only are we going to look to the closest standards that are applicable to us in cases where we do not have a local standard per se, but we have to rally back on our engineering capabilities. You know how to design these systems, you have an understanding of your outdoor conditions, so you are able to do your own calculations, but just to use those standards that are closest in application to us as a guide. So what are the effects of poor indoor air quality? Now, poor indoor air quality has been shown to cause discomfort, health issues, lower productivity, and high absenteeism amongst occupants, especially in commercial applications. Now, with the worldwide COVID-19 health crisis still ongoing and for the foreseeable future, engineers and building managers should ensure that standards are being maintained and are exceeded to provide good indoor air quality, especially in high-risk applications like call centers, hospital waiting rooms, and prisons. Of course, these are just a few. So we need to ensure building managers, engineers, from the design or retrofit perspective, that these standards are being maintained or are being exceeded. And for applications, or for buildings, I should say, that do not have a proper consideration for indoor air quality, get with it, please, because it is dangerous, not only to the bottom line of the businesses, but most importantly to the health and well-being of occupants. There are instances where the building indoor air quality is poor or was not considered in the initial HVAC design. The building becomes therefore a reflection of the poor quality of the indoor environment. And in some instances, definitely in some instances, the building may develop sick building syndrome, SBS, and occupants may show and develop symptoms of building related illnesses. And there are quite a few examples across our beautiful island. Now, sick building syndrome is caused when indoor air contaminants, like the ones I listed earlier, are trapped in an indoor air environment. Now, and this happens when you do not have a properly designed, installed and maintained ventilation system. The side effects include fatigue and poor concentration, dry, itchy skin, eye, nose, mouth irritation, headache, and occasionally nausea, lower respiratory symptoms. And these are just a few of the symptoms that are listed by ASHRAE in 2009. So the list could have been vastly increased since then. And of course, it affects the health of whatever business it is. Because if you have people feeling this unwell, can you imagine how low productivity will be in a building like this? According to Burge et al., the overall increased commonness of health complaints amongst office workers is typical of sick building syndrome. Now, building-related illness, BRI, is more specific. They have a known source and may have different symptoms. They are clinically diagnosed illnesses that are directly related to an environment with poor indoor air quality. So now, when I was doing some research and I was looking at the list of indoor building-related illnesses, I was shocked. It was a vast list. It was very scary to know that. I mean, I knew, but just seeing them on paper is quite scary. So, just to name a few, you have building-related asthma, which is caused by mold, environmental tobacco smoke, and dust mites, with symptoms ranging from coughing and wheezing to chest tightness. So can you imagine if somebody goes into a sick building who already has asthma? So it could just make the situation worse, or could vastly affect that person's health and well-being and the company's bottom line. Central nervous system issues, definitely caused by carbon monoxide, organic compounds, noise pollution, poor lighting, and work stress, with symptoms including headache, fatigue, irritability, and difficulty concentrating. So a sick building is not only caused by indoor air quality. It can also be affected by different building services, including acoustics, lighting, and so on. So it is basically a conglomeration of these different building services that can affect the whole life of the building and the well-being and health of persons who are occupying the space on a daily basis. Now, building-related illnesses are different from sick building syndrome, as building-related illnesses require a prolonged recovery time after leaving the building. Other examples of building-related illnesses include allergic reactions, infectious diseases, definitely involved in infectious diseases like COVID-19, dengue, and so on, and even cancer. A couple years ago, you couldn't turn on your TV without hearing about asbestos and cancer, and certainly persons who work in certain industrial environments are exposed to different contaminants, and if they're not treated correctly, can diversely affect the health of individuals working in those spaces. So it is important to always protect persons, not only with ventilation systems and proper HVAC design, but also with personal protective devices. And what are the benefits of good indoor air quality? Of course, it's the opposite. The health of the occupants is protected, definitely. The occupants are more comfortable and productivity is increased. Now, my job is to introduce not only to design properly sized and well thought out systems, but to recommend the best type of technologies, the most efficient types of technologies. Ventilation systems are chosen based on the best fit for the application and must be incorporated into the heat load and other design calculations for the space, of course. Now, a few systems that I've used personally over the years and recommend are energy recovery ventilators, ERV. And what these systems do is that they introduce fresh air from outside while extracting exhaust or polluted or contaminated air from the space. These systems have a heat exchanger built in, so that the much cooler air that is being exhausted is able to pre-cool incoming air. So it makes it, it lowers the temperature of the outdoor air going into the space, hence reducing the heat load or the requirement for cooling once that air enters the space. So it creates a more energy efficient system with a lower heat load. You have dedicated outdoor air systems. These are mostly used in hospital applications for intensive care units, where you have one system introducing 100% fresh air, where the air is treated, purified, filtered, and introduced at 100% fresh air. In those types of systems, you have to ensure that correct balancing is done. So fresh air is being introduced, but also we have to consider the exhaust of air so as to maintain the appropriate pressures in the given spaces. For example, a room where some kind of clinical treatment or reaction is occurring, you want to ensure that no air is escaping from that room. So that room should always maintain a negative pressure. So those are things that we must consider in the design of the system, design and balancing of the system. We have outdoor air processing systems that can be incorporated in variable refrigerant flow or variable refrigerant volume systems, which are typical now to the commercial environment. And of course, we have to have our exhaust systems along with these. So we can't just be providing fresh air to the space. We have to be exhausting polluted air to maintain proper pressures within the given application. Maintenance. Maintenance is extremely important. So you make a huge investment in a system. You have a properly designed system. It is effectively designed. It is effectively installed by trained professionals. However, if it is just installed and not maintained and operated properly, the life cycle or the lifetime of that system could be reduced significantly. So an important aspect of HVAC systems in commercial buildings, I believe, is ensuring that a proper maintenance plan is put in place. So systems must be properly commissioned. I heard Engineer Boyd speak about commissioning. It is extremely important, and usually commissioning is data is usually provided in maintenance manuals, and the information is filled in by the trained installer, right? Or the engineer, the professional engineer that designed the system, does the commissioning and hands that documentation over to the building manager to show that this system was effectively installed and commissioned and left in proper working order. And then a maintenance plan should be given to the building manager as to how to maintain that system. So the system must be maintained routinely as per the manufacturer's recommendations, and of course specific to the application and location of the installation. What do I mean by this? A building located in, a system located installed in New Kingston will require far less servicing than a system installed at Carib Cement, because the level of contaminants that are in the air is definitely different, and so a different maintenance plan is required. So building managers and engineers should always request a maintenance plan from trained professionals. Design engineers must make maintenance plans, as I said, for systems to ensure longevity and efficient operation over the life of the system, to ensure that the system has the maximum possible lifetime. We want to ensure the system is maintained and operated properly. And also we want to ensure that once a system has reached the end of its recommended life cycle, we want to change the system, because over time you have more efficient technologies coming. So once it has reached the end of its life cycle, then conversations should begin as it relates to replacing or definitely refurbishing the system. So maintenance should always be carried out. I can't stress this enough, because what I've seen over the years, certainly once you've installed a system and you provide a commissioning report and you send off your maintenance plan and you say, okay, this is what you need to do to make sure your system, you know, is functioning and up and running for a long time. What we see happening is that persons don't get back to us regarding maintenance, because when you reach out to them, they say, you know, we have our own technicians, and what we usually see happening is that a couple years down the line, they call back and the system is not functioning, or there's a leak in the system, because persons that are not trained tend to damage the equipment in their servicing and maintenance of the system. So we have to ensure it is our responsibility to protect our investment by ensuring that the equipment is maintained properly. Oh, and one last thing as it relates to maintenance. Whoever it is that supplied your equipment or is maintaining your equipment, you want to ask them if they have ready access to replacement parts. Because no matter how good a system is, there might come a time when something goes bad or something goes wrong and you want to replace those parts. And especially if you don't have a redundant system, you want that part replaced pronto, or as soon as you possibly can. So that is a question to ask your supplier or your service supplier. So in conclusion, the duty of the engineer is that we have an ethical duty to create solutions in all avenues of our society to ensure that Jamaican citizens are all working in safe and healthy environments. The quality of the air in our commercial buildings is as clean and as safe as the engineering design. And the design is as good and as trained as the engineer is. So we want to ensure that the engineers are professional and trained, and also the design and maintenance of the building management system, the building HVAC system is quite important. So we want to ensure that we are using reputable reputable firms in our procurement of equipment, installation, maintenance, and so on. Finally, the substantial investment in an effective and efficient HVAC system with optimal outcomes are best achieved through the guidance and input of professional engineers and reputable contractors and suppliers. So if we want a system that is doing what it should, it is maintaining indoor air quality, it is keeping occupants healthy and thermally comfortable. We want to ensure that we have a collaborated design. So we bring all of our stakeholders together, your HVAC, your mechanical system designer, your electrical systems designer, your plumbing engineer. Everybody comes together with civil engineer, the architects, and create a wholesome project that has at the end the occupants in mind. Because what use is a beautiful building with all of these mechanical systems designed if you can't occupy the space, if the systems are not working properly. So as engineers, we must always remember the end goal, which is to ensure that the customers and the occupants of our buildings are comfortable and are safe. Thank you.
Thank you very much, Engineer Kellesia. They have a few questions, and I'm now hand over to our administrator.
Thank you very much, Mr. Ricketts. Our first question comes from an anonymous attendee. The person asks, what instruments or devices are recommended to measure air quality? Are there handheld devices?
Okay, yes, you do have handheld devices that can measure air quality. Certainly, I recommend carbon dioxide detectors. Usually they can detect both carbon dioxide and relative humidity within a space. So you can get those handheld devices where you can put them down on a desk within a space, leave it for a couple of minutes, and it will sense the levels of carbon dioxide and relative humidity within a space. Versus something that is connected to a control system which controls ventilation. But definitely you do have handheld devices that can give you a clear picture of what's going on in your air.
Thank you. Our next question is from Kevin Irvine. He asks you to comment on the relative cost of HVAC solution, that is implementation versus running. And
Repeat the question. I didn't hear the first half of the question.
All right. So they're asking you to comment on this, which is relative cost of HVAC solutions, that is implementation versus running, and impact, if any, on overall system operation efficiency versus benefit, and customer client awareness as per needs requirement and assessment of environment done, and education solution on options and required frequency of maintenance for life cycle.
Okay, let me just answer the question how I think I understand, not understand exactly what they want, but what I try to tell my clients is not, I understand that capital cost is important, but what we want to do is to consider the overall cost. Do you want to install a system that is cheaper upfront and then down the line you have to replace it 2 years later, or maintenance is ridiculously expensive? No, you want to install a proper system that might be expensive upfront, but however, during the life cycle of the equipment, the maintenance and operation is relatively smooth sailing, and within a few years, with its efficiency, it pays for itself. So doing an analysis beforehand is important. So that's something that you can request from your consulting engineer or your engineering firm. Give us a cost analysis, break it down. How much is it going to cost? Compare different equipment, because you have different types of equipment you can compare. Some more efficient than others. Compare the upfront cost and give us the life cycle maintenance cost, and then at the end of the day you can see which one is most suited for your application.
All right, thank you.
I think that
Question.
answers part of his question, I hope.
Well, if anything, you can type another response, type your answer to him in the chat.
Okay, great.
All right, so another question from him. So he asks, are there tone and planning regulations to guard against systems being designed or implemented on other premises, that is effluent air or other, being released, potentially affecting neighboring premises? Now, do you know of computational fluid dynamics, CFD, based environmental studies being done to in support of urban and rural development? There is nothing that quality of outdoor and wind dispersion studies of the environment can also affect building HVAC system performance.
So I'm not aware. I can look into it, but I'm not aware of any research being done, but certainly it is something worth considering and looking into, because as I said before, it is a waste when you install a ventilation system and then, you know, you put it at the best location and 2 months down the line, persons are calling you, the scent in the space is unbearable. I have an installation like that at the wharf, where we installed an expensive HVAC system, beautiful air conditioning, ventilation system. But a couple months after the system was commissioned and handed over, there was a really bad scent in the space, and we found out that it was the wind carrying scent from a manufacturing area further down the road that is affecting the space. So we had to basically redo a lot of that work to facilitate that which could have been prevented by proper research. So that's definitely something we should definitely look into. And even though we did all that corrective work, they are still being affected. So that's definitely something that I should look into. Thank you for that question.
All right, thank you. Next question is that, are UV light systems available locally for residential homes?
Yes. Yes, they definitely are. If you have a residential air conditioning system, you can get UV light solutions. You can call your local suppliers. Most reputable, CAC 2000, you can contact, my company does not do so much residential, we do commercial, but you can contact us too, we look into it. Dendock and Company Limited, CAC 2000 Limited, Geddes Refrigeration, RL certainly. I think RL mostly does commercial if I'm not mistaken, but they can also be contacted. But I know for a fact there are definitely residential solutions, including UV lamps and also air purification, room air purification systems that have UV lamp incorporated.
All right, thank you. Now,
And
Martin,
if you're at a loss for a supplier, you can also go onto Instagram and type in what you're looking for. You will definitely find hashtag UV lamps somewhere, hashtag air purifiers, or hashtag something. So we can utilize those resources also to get the answers that we're looking for as it relates to suppliers and equipment.
all right, thank you. Now, Martin says that, seeing that Cornwall Regional Hospital has been deemed a sick building, what steps can be put in place to improve the HVAC systems as to both combat COVID-19 and as well as to mitigate the repetition of another case of a sick building?
Yes, Cornwall Regional is being deemed a sick building. I would not say that it was not properly designed. I've spoken to a few of the engineers that designed that system or were a part of the design team, and what they're saying is that it's not the design of the system that caused Cornwall Regional to develop sick building syndrome, but the maintenance. And that is why I stress how important maintenance is. You can design the most elaborate, fancy, efficient, well-equipped system, but if it is not properly maintained by trained professionals, then it is going to run down over time and it is going to defeat the purpose of the design. But certainly what they can do is to incorporate what I've discussed before, creating a harmonious balance between the different building services. And what that will require is a coming together of the different engineers, the architects and designers to create a wholesome design, one in which all the systems are working together to create the best environment for the patients and the medical professionals in that facility. But it is going to take a lot of work, definitely, but it can be fixed. But what we need to do is to learn from our mistakes, learn from Cornwall Regional's mistake. You can't install this beautifully arranged system and then ignore it and expect it to continue doing what it's supposed to be doing. It has to be maintained.
All right. Thank you very much, Engineer Ebanks. We have one more question from Martin. Now he asks, what are the international standards that governs the proper disposal of HVAC systems at the end of their life cycle?
Certainly NEPA has the guidelines that speak to the disposal, not only of the equipment, but of the refrigerant in the equipment. And I hope persons are adhering to the standards. So the refrigerant in the equipment, first and foremost, before it is disconnected, must be recovered. As it relates to where the recovered refrigerant goes after, there's a gray area right there. But what my company does, what DENDOC does, is to reuse recovered refrigerant. Refrigerant is quite harmful to the environment. As we speak, persons are trying to develop more and more efficient or less harmful refrigerant for the environment. But right now, the refrigerant that we use is definitely very harmful to the environment. So we recover it, purify it, and then reuse it as much as possible. But NEPA has various guidelines as it relates to disposal of equipment and refrigerant. But we definitely try to dispose of it as best as possible to standard.
So, thank you very much, Engineer Ebanks. Since there are no more questions, I'll hand over back to Engineer Ricketts.
Thank you very much, Engineer Kellesia.